Okay, on this next video, we're going to ignore this first problem because I had posted on the slide, so you can just refer to that. It's pretty simple. These situations, these angles are created outside of the circle. So when it's outside, you look for your intercepted arcs, like right here, and you're actually going to take the bigger one, subtract the smaller one, multiply it by half, and that will give you the angle. In this case, we know the angle, so the angle is 31. And it will be half the intercepted arcs. They're different. So start with the bigger one and subtract the smaller one. Again, this is a situation that you have if you multiplied the half through, you'd get a fraction. So I'm just going to multiply both sides by 2, and I get rid of that half. And you don't have to multiply every term because this was in front. It was multiplying every term. And then this is 62, and you get equals 92 minus 3x. And of course, you know that that is negative 30 when you move it over. And then x is 10. And if you plug that in, 92 minus 3 times 10 would be 30, is 62, and half of that is 31, so that makes sense. All right, this next problem, a little bit more difficult. You have to understand that this right here is a diameter. So if that's the case, if this is a diameter, this is a semicircle. And this semicircle would measure 180 degrees. So again, the angle is created outside the circle. So we're going to say 45, because we have the angle already, is equal to half the difference of the intercepted arcs. And the intercepted arcs are here and here. All right, that's if you look at the lines. Here we have a secant, and this is a tangent. So we're going to take 180, we're going to subtract the 10x. In this problem, you actually could solve it two ways. You can distribute, and you don't get fractions, or you could multiply both sides by 2. It doesn't matter. Here I'm going to subtract 90 both sides, and I get x is equal to 9. And that would make sense. The bigger arc is 180. 10 times 9 is 90. If I take 180 minus 90, I get 90, and I take half of it, I get 45. And this next one in our example, we just have to be smart and understand we need to figure out what this arc is. So to figure out what that arc is, I'm actually going to do 360. And I know the other two arcs of 170 and 177, I should say, and 102. And so, I don't know, what is that? 360 minus 2. It's been a long day. I'm going to just do on my calculator. 279 is 81. So this arc right here is 81 degrees. So again, we have a tangent and a secant. The arcs that were intercepted by those lines to form this angle are right there and here. Okay? So we did need to use the 102 to get this 81. And what you're going to do here is say x is going to be equal to half 177 minus 81. X is going to be equal to half, what is that, 96? Does that seem right? Thinking. And then that is 48 degrees. All right. There's our second video. All done. Not too bad.